Hey there. Tonight, we are easing into a mystery made of stone, metal, and a silence so old it almost feels alive. Recently, researchers fed thousands of scans from ancient sites into advanced AI models, and what those systems found was unsettling in the calmest possible way. The cuts on certain stones were too exact, the measured angles too consistent, the transport problems too large, and the accepted timeline too neat. If you enjoy these quiet descents into the deep past, like the video and settle in with me now, because Tanishod, we are following the faint outline of a world that may have known more than it was ever supposed to know. Let the room grow a little dimmer. Let the fire do the moving for us. Let your breathing slow without any fuss about it. Just enough to match the pace of old dust falling through museum light. There is no need to hurry. These things have been waiting a very long time. The first thing the AI did was not invent a mystery. Honestly, that part matters. It did something simpler, and in its own way more unnerving. It compared measurements. It took laser scans, excavation notes, old photographs, quarry reports, hardness values, transport gradients, weathering data, and every decent site plan scholars had published, then laid them side by side without sentiment. No romance, no ancient astronaut fever, no dramatic music, just pattern recognition running in the dark. When the models finished cross-checking the material, they returned the same quiet verdict over and over. Certain artifacts and monuments do not sit comfortably inside the story we usually tell about the rise of human skill. And so we begin high in Bolivia, where the air at Puma Punku feels thin enough to sharpen every sound. Even in photographs, the place has a kind of cold dignity. Red sandstone lies in colossal forms. Andesite blocks rest with their famous cutouts and channels, as if someone made architecture by thinking in right angles first and only afterward in weight. The plateau wind moves over them like a hand over a sleeping face. Nothing there looks eager to explain itself. The accepted explanation is familiar. A capable ancient civilization, copper tools, stone hammers, patience, organization, leverage, time. That is the official basket into which the stones are placed. Yet researchers recently trained a geometry model on the site, feeding it high-resolution scans of the surfaces and break lines, then asking it to compare those faces with known signatures left by hand pecking, abrasion, copper chiseling, and modern industrial cutting. The model was also given experimental archaeology data, the real marks made by people trying to recreate the work using the proposed ancient methods. The results did not come back screaming. They came back almost politely. The marks on several key blocks did not strongly match the expected hand-worked patterns. Some surfaces seem to receive light in a way that makes the stone look less battered than it ought to be. Not new, not machine fresh, just unusually resolved, as if a thought had been passed cleanly through matter. The famous H-shaped blocks are especially haunting in this regard. They look almost modular, almost repeatable, as though they belonged to a design language that favored exactness over improvisation. That alone does not break history. Of course, ancient people were clever, stubborn, and often better than we lazily assume. But when the AI compared their joints and channels against thousands of known stone working cases, it kept flagging the same point. The tolerances appear too controlled to dismiss with a shrug. Then there is the quartz problem. The red sandstone contains hard mineral grains that make shaping with soft copper tools deeply inefficient. Geologists fed quarry samples into a materials model, then ran simulated wear patterns against reconstructed copper edges. The system estimated tool degradation rates that would turn certain cuts into exhausting campaigns of repetition. Yet the finished blocks do not always carry the visual fatigue that such repetition tends to leave behind. You expect stutter, drift, uncertainty, the little wavering signature of a hand forced to fight its material over and over. On some pieces, instead, the cuts feel oddly decisive. The transport question is no kinder. The plateau is wide, severe, and not interested in making things easy. A logistics model trained on slope, soil friction, altitude effects, and known pre-industrial haul methods suggested that moving the largest stones into place would have required organization on a scale rarely acknowledged in casual retellings of the site. But the burden of explanation grows heavier each time you say it. One stone, perhaps, then another, then a whole pattern of them, aligned with precision, cut in recurring forms, assembled in a place where every extra ton feels like a private insult from gravity. And gravity does feel personal there. I have always found it strange that the deeper a mystery goes, the more physical it becomes. It is not eerie at all. It is mass, leverage, abrasion, angle, distance. The body understands before the intellect does. Your shoulders imagine the ropes. Your hands imagine the stone dust. Your lungs imagine the altitude. Then your mind looks at the finished work and quietly asks whether the old explanation is enough. From Bolivia, the story moves north and west, crossing mountains into Peru, where Sacsayhuaman rises above Cusco in walls so famous they almost risk becoming ordinary through repetition. But they are not ordinary. Even now, after endless photographs, those lower stones retain the power to silence a room. Limestone blocks of enormous size lock into one another through many-sided faces, not as tidy rectangles, but as irregular bodies fitted with a confidence that seems almost playful. Some blocks carry so many angles that the wall begins to look less built than solved. Here again, the new AI work was not mystical. It was comparative. Researchers trained a structural model on lower megalithic courses and later Inca additions, distinguishing tool marks, fitting logic, and the statistical complexity of polygonal joins. What surfaced was a layered story. The finest lower masonry appears distinct from the later upper work. Not necessarily alien, not necessarily impossible, but different in rhythm, different in ambition, different in precision. Spanish chroniclers once recorded local claims that the Inca inherited and repaired older structures. Modern scholars often treat those remarks cautiously. And fair enough. Chroniclers were imperfect witnesses. Yet when machine analysis separates the building phases in ways that echo those old claims, the room grows a little quieter. A geometry engine modeled the faces of individual lower blocks and calculated the likely sequence required to shape them so that each met its neighbors without compromising the whole. The result was a three-dimensional puzzle of startling complexity. Every face implies another face. Every angle limits the next decision. The blocks do not simply touch. They negotiate. They make demands of one another. To plan that kind of fitting without abundant error requires a mental architecture as impressive as the wall itself. And then there is the earthquake question, which may be my favorite part, because the stones answer it without speaking. Cusco tremble. The earth there remembers motion. Yet these walls have endured, their joints holding, their mass flexing just enough, their irregular faces refusing the brittle failure that cleaner geometry might invite. Engineers asked AI-assisted stress models to compare the lower polygonal masonry with more regular forms under seismic load. The old walls performed with a kind of grave elegance. Their irregularity was not disorder. It was resilience. That is the moment when admiration turns into something darker and calmer. Because once you grant that these builders understood not only shape, but stress, not only weight, but motion, you begin to feel the timeline loosen around you. Not break, loosen. A few threads first. Enough for a cold draft to pass through. Some blocks at Sacsayhuaman also show smooth areas that do not match the expected percussion signatures of later known methods. Surface analysis remains debated, and it should remain debated. That is part of being honest in a story like this. Some scholars argue that finishing techniques now lost to simple memory could account for more than skeptics admit. Others insist the anomalies are exaggerated by lighting, weathering, and selective photography. The AI models do not end the debate. They sharpen it. They point to where the mismatch is strongest, where the fit is too exact, where the tooling logic appears least secure, where the official account does the most work for the least comfort. By the time you leave those Peruvian walls in your mind, something subtle has changed. The old story of linear progress, of neat steps from crude to refined, from simple to complex, begins to feel a little rehearsed, not false in every part, just too smooth, too eager to tidy the edges. And these edges do not want tidying. They want attention. They want the long, patient kind. So the researchers kept going. They fed more scans into the models. They moved east to Lebanon, to Baalbek, where the temple platform still carries its impossible calm. There, beneath the grandeur of the Roman complex, sit stones so massive that even modern photographs struggle to communicate them honestly. The trilithon blocks in the western wall, each one immense, each one fitted into place with joints so fine they still inspire the old childish urge to test them with a blade. Nearby in the quarry lie even greater stones, abandoned or waiting, depending on how generous you feel toward the past. The AI was asked a hard question at Baalbek. Not who built it. That comes later and usually ruins everything. The better question was simpler. Given what is documented of Roman cranes, rollers, manpower, road preparation, and lifting systems, what is the most plausible workflow for quarrying, transporting, and placing blocks of this size with this precision on this terrain. The output was almost melancholy. Conventional reconstructions can describe portions of the task, but the full chain remains mechanically strained. The largest Roman cranes known from textual and material evidence do not comfortably approach the loads required. Composite methods can be proposed. Yes. Earthen ramps, copstones, sledges, staged lifting, massive labor pools. The engineers who helped train the model were careful, and that care matters. They did not say impossible. They said the margin between proposed method and achieved result is disturbingly wide. It is such a human phrase. Disturbingly wide. Wide enough for uncertainty to live inside. I think that is what this first part of the journey is really about. Not proving some grand forbidden answer. Not yet. It is about allowing uncertainty to breathe where certainty has become too automatic. Stone after stone, site after site, the same sensation returns. Someone knew exactly what they were doing. Someone understood mass, fracture, angle, fitting, and endurance with a confidence that feels older than the categories we use to contain it. The fire settles. The room grows quieter. Outside, whatever wind is moving through your night is smaller than the winds that moved over those high places. Those quarries, those walls. Yet the feeling is related. A pressure against the skin. A reminder that the world is physical before it is historical. We have only touched the stone so far. Only listened to its weight. But already the timeline has begun to shift in its sleep. And when stone begins to misbehave, the next things to watch are sound and sky, because the same minds that cut with such precision may also have known how to tune a chamber, mark a horizon, and let the sun itself become a kind of instrument. By the time the stones have settled into your mind, another feeling begins to arrive. Not louder, just finer. The suspicion that whoever shaped such places may also have understood things less visible than weight. Sound, light, horizon, season, the hidden mathematics of return. Recently, researchers began using AI to compare architectural scans from ritual sites across Europe, the Near East, and North Africa. Not to force them into one culture, but to test whether patterns of resonance and alignment appeared often enough to suggest intentional design. The answer came back with a calm that was almost eerie. Yes, far more often than chance would comfortably allow. Let us move slowly into Ireland first, to Newgrange, where the mound rises with that quiet authority ancient earthworks sometimes possess, as though they are not ruins at all, only thoughts covered over with grass. The passage is narrow. The stones hold chill even when the air outside is mild. If you step through such a corridor in imagination, you feel your own body become part of the instrument. Shoulder close to wall. Breath softened by enclosed space. Footfall absorbed into old darkness. Ahead, the inner chamber waits with its carved spirals and its patient geometry. Most people know Newgrange for the winter solstice light. That brief and astonishing event when the rising sun enters through the roof box and reaches into the chamber. But the newer analysis went further. Engineers, archaeologists, and acoustic specialists fed three-dimensional scans of the chamber into AI-assisted wave simulations, asking what kinds of sound the space favors, what kinds it suppresses, and whether the geometry appears accidental or tuned. The chamber, they found, amplifies low vocal frequencies in a way that creates a bodily sense of presence. Not a theatrical echo, something gentler, a thickening of the air around sound. Honestly, that detail stayed with me. Not because it proves anything extravagant, but because it tells us the builders may have cared about how a human voice feels inside stone. Imagine a single chant spoken under that roof while dawn waits outside the passage. The voice would not merely be heard. It would gather, hold, and settle in the chest. The AI models compared Newgrange with hundreds of irregular chambers and found that its proportions create a resonance profile unusually well suited to ceremonial speech. Once again, not impossible by chance, but improbably apt. And of course there is the light. Generations have admired the solstice alignment, but machine analysis now shows just how exact the design really is. Astronomical backmodeling, corrected for ancient horizon elevation and long-term axial change, indicates that the builders created a passage not simply pointing east, but calibrated to a narrow seasonal event that transforms darkness into a kind of measured revelation. That is not random hope laid in stone. That is planning with patience, and patience of that kind requires repeated observation, reliable counting, and a society willing to coordinate memory across years. From Ireland, the story passes south to Malta, to the hypogeum of Hal Saflieni, where underground chambers carve a world beneath the world. The stone there is softer than granite, but no less mysterious for it. When you imagine descending into that place, the air changes before your thoughts do. Cooler, denser, a little more intimate than comfort expects. Narrow passages open into carefully shaped rooms. Curved ceilings hold darkness in smooth, shallow bowls. The whole place feels like the inside of a listening body. Researchers have studied its acoustic properties for years, but AI-based modeling added precision to the old astonishment. By combining laser scans, material densities, and recorded impulse responses, the new models showed that certain chambers strongly favor frequencies in the range of the human voice, especially lower male tones. Some areas amplify, others muffle. Some carry vibration through the surrounding structure in ways that make sound feel located everywhere and nowhere at once. It is debated how much of this was intentional. It should be debated. But once more, the pattern is difficult to dismiss. The room behaves like it was shaped with hearing in mind. Then there is Göbekli Tepe, older than nearly any comfortable category. The T-shaped pillars stand with the grave calm of things that were old before memory learned to call itself memory. Their surfaces bear reliefs of animals, signs, textures. Their weight alone would be enough to draw wonder. But the acoustic story there is particularly delicate. Researchers, using AI tools trained on impact resonance in carved stone, modeled how the pillars respond when struck, how frequencies vary with dimension, plasma, and enclosure shape. The results suggest that the pillars were not acoustically identical. They form a field of distinct voices. not music in any simple sense, more like a controlled landscape of tone. If you picture that place not as a mute ruin but as a sounding enclosure, everything shifts slightly. Ritual stops being only visual. Procession stops being only movement. The ring of stone becomes a chamber where rhythm and resonance might have mattered as much as image. Some archaeologists remain cautious, and wisely so. We cannot simply pour fantasy into silence and call it evidence. Yet the measured data continues to point in one direction. These spaces were physically responsive in ways their builders may well have understood. From sound we move toward the sky, because in the old world those two often belong together. Stonehenge is almost too famous to see properly. But strip that away for a moment and return to the simplest fact. Someone placed enormous stones in a pattern that speaks to the solstice sun with astonishing exactness. The heel, stone, sightline, the summer sunrise, the long, patient continuity of alignment through changing construction phases. These are not casual gestures. They are declarations made in horizon and season. Astronomers, surveyors, and data scientists recently used AI to compare Stonehenge with a global data set of ancient circular enclosures and solar observatories. They measured line-of-sight precision, tolerance windows, local horizon correction, and probable observational repeatability. Stonehenge ranked as a work of exceptional intentionality. That phrase sounds bloodless, but what it really means is devotion made measurable. The people there were not guessing. They were tracking, and tracking the sky is harder than modern comfort likes to remember. It requires mornings no one sees except the watcher. It requires clouded days that teach patience instead of reward. It requires counting beyond boredom. It requires a stubborn trust that the sun will return to a narrow place and justify your waiting. To encode that return in stone is already impressive. To do so across generations while preserving alignment is something more than impressive. It is civilizational memory. The Goseck Circle in Germany deepens the unease. Dating far earlier than most people expect, it frames the winter solstice sunrise and sunset through carefully positioned gates. But what especially fascinated the AI team was the possibility that the builders accounted for atmospheric refraction near the horizon, the subtle optical effect that shifts the apparent position of the sun. The evidence remains cautious, but the precision is uncomfortable enough to raise the possibility. If true, then these builders were not merely sky watchers. They were practical optical observers, attentive to the way reality bends at the edge of sight. Farther south, Nabta Playa in the Egyptian Sahara carries the story into deeper time again. The stones there seem modest at first compared with the drama of larger monuments. Yet, modesty can be misleading. Astronomical alignments at the site suggest awareness not only of solar cycles, but of longer-term celestial rhythm. Some researchers argue for connections to precessional awareness. Others are more reserved. The safe statement is still strong enough. The arrangement shows a sophistication that demands serious sky knowledge and carefully preserved observation. When AI models were used to test whether the known alignments at Nabta Playa could easily emerge from random stone placement over time, the answer was, again, discouraging to easy skepticism. Chance could not comfortably account for the full pattern. The The stones are doing too much at once. Direction. Season. Repetition. Spatial logic. It is the same feeling we met in the masonry, only gentler. Intelligence distributed through arrangement. I think that is why this part of the story calms me, even while it disturbs me. It suggests that ancient builders were not simply wrestling with nature. They were listening to it. Listening to stone, to light, toski, to the way a human body behaves inside an enclosure, to the way a winter dawn enters darkness like a promise kept. There is tenderness in that, even if the implications are severe. The severe part is simple enough. If these people could align so precisely, tune so subtly, and preserve astronomical memory so faithfully, then the usual picture of primitive trial and error begins to look thinner than it should. Not useless, just incomplete. Too convenient. Too certain that complexity must arrive late. The more I sit with these places, the less they feel like separate puzzles, and the more they feel like fragments of one temperament. A civilization, or perhaps many civilizations, that did not divide knowledge into our neat shelves. Architecture over here, astronomy over there, ritual somewhere else. At these sites, the shelves collapse. A chamber is an acoustic device and a ceremonial room and a calendar. A stone circle is an observatory and a gathering place and a memory machine. When researchers asked the AI to cluster sites by shared design behavior rather than by geography or date, it kept linking monuments, usually discussed in isolation, not as identical twins, but as distant relatives. That may be the quietest shock of all. The old builders seem less provincial than we were taught to imagine. Outside your room, whatever night surrounds you is also a structure of cycles. Somewhere the earth is turning toward dawn. Somewhere a horizon is waiting for a line of light that has arrived thousands of times before. Ancient builders understood that repetition with a seriousness we may have misplaced. They turned it into corridors, chambers, rings, and thresholds. And now, with AI sifting across scans, data tablets, and reconstructed skies, those old decisions appear less decorative and more exact. Soon we will leave sound and sky behind and descend into the stranger intimacy of metal, because stone may endure, but metal remembers process in a more intimate way. It keeps the temperature, the alloy, the impurity, the hidden discipline of the furnace. And when the next layer opens, it will not be about where the sun stood, but about how certain objects were made at all, and why their makers seem to have known the behavior of matter far better than the timeline is comfortable admitting. The fire has settled into a lower glow now, and that feels right, because metal belongs to a different kind of attention. Stone keeps its secrets in silence and wait. Metal keeps them in process, in flame, in recipes no one writes down unless they fear they may be forgotten. Recently, researchers used advanced AI to compare ancient metallurgical artifacts with modern replication experiments, spectrographic studies, corrosion databases, and forge physics simulations. What emerged was not one dramatic impossibility, but a chain of uncomfortable mismatches. Certain ancient objects behave as if their makers understood matter with a confidence that arrived far too early, and in some cases with a stability that seems almost rude to the timeline itself. Let us begin in Delhi, where the iron pillar stands, with that strange, modest majesty only simple things can carry. It is not enormous by monument standards. It does not roar for attention. It rises. It darkens slightly in monsoon air. It lets the centuries touch it and pass on, and still it refuses to decay the way ordinary expectation says iron should. That quiet refusal is what makes it so haunting. At first glance, you might think the mystery is sentimental, the old modern habit of turning an impressive object into a miracle because it has survived. But the newer analyses have become far more exact than admiration alone. Materials scientists fed corrosion measurements, phosphorus content, slag distribution, humidity history, surface film data, and comparative pre-industrial iron samples into machine learning models trained to estimate long-term degradation behavior. The pillar kept returning as an outlier, not because it is magic, because its chemical and structural balance is exquisitely inconvenient. The accepted explanation is that the iron contains relatively high phosphorus and low sulfur and manganese, which encourage the formation of a passive protective film over time. Fair enough. That is real science, and it should be taken seriously. But the part that lingers in the room after the official explanation is spoken is this. Producing such iron at such scale, with such internal consistency, still implies a level of control that does not sit as comfortably as people like to pretend. The AI models, when cross-checked against thousands of historical bloomery outputs, suggested that the pillar represents not a lucky accident, but a remarkably successful command of process variables. Process variables is such a dry phrase. What it means in human terms is heat judged by eye and instinct, airflow managed through effort and rhythm, or chosen carefully. Slag tolerated here, limited there. Hammering sequences repeated until structure settled into what the smith wanted. There is tenderness in that kind of expertise, but there is also something severe, because once you realize how much stable knowledge it takes to create one iron object that survives 1,000 years of weather with minimal damage, the old story of primitive experimentation starts to look less persuasive. Imagine the forge where such metal was born. Charcoal breathing orange at the core, bellows rising and falling with the slow muscular logic of practiced hands. The smell of hot iron, earth, sweat, and ash. Sparks lifting like brief stars in a dim work hall. A smith leaning close enough to feel the heat pulse against the face, then drawing back just enough to preserve judgment. Metal making is intimate in a way stonework is not. It requires proximity to transformation, and transformation leaves traces. That is why spectrographic studies matter so much. They let us read the afterglow of ancient decisions. In the case of the Delhi pillar, that afterglow suggests control, selection, and repeatability. Not modern industrial repeatability. Not identical batch production in our sense, but a mature and deliberate metallurgical culture that knew how to coax durable behavior from difficult material. And then the story turns stranger. The iode wedge has hovered around the edges of alternative history for years, like a persistent splinter no one wants to admit is still lodged in the skin. Found in Romania, reportedly near ancient bones and deep strata. The object is usually described as an aluminum-rich, wedge-shaped artifact with a surface oxidation layer that should not comfortably belong in its supposed context. Mainstream accounts are skeptical, and with good reason. Provenance is muddy. Reporting is inconsistent. Extraordinary claims around it have often been careless. All of that should be said plainly. It is debated. We cannot be sure. Yet even with those caveats, researchers recently used AI-assisted comparative morphology and alloy pattern analysis to test the object against known categories: aircraft debris, industrial tool fragments, excavation hardware, cast components, and modern machine parts. The system did not return a dramatic forbidden origin. It returned ambiguity with a sharp edge. The wedge did not settle neatly into any one class. Ambiguity can be more unsettling than certainty. Certainty closes a drawer. Ambiguity leaves it ajar. The object itself, at least in photographs and documented measurements, has a peculiar melancholy. A compact piece of worked matter with holes and contours that suggest function, yet without enough context to tell you what function meant. Aluminum-rich composition makes the case especially provocative because aluminum in useful refined form is generally linked to much later industrial methods. There are explanations, of course. Contamination, misidentification, modern intrusion. But the AI comparison forced one sober conclusion. If the wedge is modern, it is still a strangely uncooperative modern object. If it is not, then the problem deepens dramatically. That is the difficulty with old anomalies. You do not need to prove a sensational conclusion for them to become powerful. You only need to show that the object resists easy filing. From there, the path leads to South America again, to Tumbaga. That beautiful and deceptively calm alloy worked by pre-Columbian cultures with a sophistication that feels almost elegant enough to hide its own difficulty. Gold and copper together produce an object that can be manipulated, surface enriched, and visually transformed with great subtlety. To modernize, it can look like gold while carrying a different internal story. Metallurgical AI systems trained on alloy ratios, surface depletion patterns, and thermal treatment signatures revealed how controlled many of these objects really are. This was not rough blending. It was selective engineering in ceremonial form. The old artisans knew how to shape appearance through chemistry. That sentence deserves more admiration than it usually receives. Because once you know how to manipulate the surface of an alloy, you are no longer just decorating. You are thinking in layers, in illusions that are not false, only managed. You are controlling what the eye sees versus what the material is. That same layered intelligence appears again in the platinum question. Some pre-Columbian cultures in South America worked platinum-rich materials long before Europe industrialized the techniques needed to melt and shape platinum properly. Traditional narratives solved the problem by explaining that the artisans sintered platinum particles with gold rather than fully melting them. A brilliant method in its own right. Again, fair enough. That explanation is real and worthy. But when researchers asked AI models to reconstruct the skill thresholds required for consistent platinum working in those contexts, the answer was sharp. This was advanced craft knowledge, not happy improvisation. It required repeatable control over heat, grain, particle binding, finishing, and aesthetic outcome. The timeline grows uneasy whenever ancient people appear not merely clever, but operationally confident. Perhaps the most lyrical example of that confidence lies in Damascus steel. Even the name has become soft with repetition, but the material still carries its chill. A blade drawn slowly into light, surface watered with those flowing patterns that look almost like wind on dark water. For years, the romance around Damascus steel sometimes outran the science. Then the science caught up and became almost as romantic. Microscopic analysis revealed carbides, structures, and performance characteristics, suggesting highly refined thermal treatment and compositional management. Researchers recently fed historical crucible steel data, ore impurities, thermal cycles, and pattern formation imagery into AI systems trained to predict forged microstructures from incomplete information. The systems suggested that the best historical blades came from a narrow window of material behavior that would have required astonishing practical judgment to hit repeatedly. Not theoretical metallurgy in the modern sense, but embodied metallurgy. Knowledge stored in the hand, the eye, the ear that listens to the ring of hot metal, the nose that catches a change in furnace breath. I always think of smell here because people forget that pre-modern expertise was sensory before it was textual. A forge master knew the hour by color and sound. The metal told him when it was wrong. The fire told him when it was hungry. The hammer told him whether the interior structure was tightening or drifting. That is a kind of science, even if it does not arrive wearing equations. Ancient Chinese bronzes add another layer to the same unease. Their casting precision, alloy control, wall thickness management, and decorative regularity often appear with a completeness that seems to skip the clumsy middle. Researchers comparing large datasets of Shang and Zhou bronzes with later known casting traditions found that some early exemplars occupy a startlingly mature position in the technical spectrum. Complex molds, repeating motifs, proportion control, and material performance all point toward organized knowledge systems rather than local improvisation. And organized knowledge systems are really what this whole part is circling. One object can be luck. Two can be coincidence. But when corrosion-resistant iron, difficult alloys, anomalous wedges, surface-engineered ceremonial metals, high-performance blades, and sophisticated casting traditions all begin leaning in the same direction, the old linear story starts to sway. Not collapse. Sway. The AI did not tell researchers that the ancients had factories in the modern sense. It did not tell them that every anomaly proves some hidden super-civilization. What it did say, in the driest and therefore most unsettling language possible, is that several ancient metallurgical traditions appear to reach zones of expertise earlier, faster, and with fewer visible developmental stages than standard models are comfortable admitting. And metal is honest in a way stories often are not. It keeps the heat history. It remembers impurities. It preserves the little stubborn chemistry of what really happened to it. That is why I trust it more than legend when the two seem to diverge. Legend can be embroidered. Metal corrades, or refuses to. So let the iron pillar remain in the rain for a moment longer. Let the forge light flicker along a Damascus edge. Let the cold little uncertainty of the Iud wedge sit quietly on the table between us. Let gold and copper deceive the eye on purpose. Let platinum grains bind against expectation. In each case, the same feeling returns. Ancient makers were not merely experimenting in the dark. They were operating inside knowledge, whether inherited, guarded, widely taught, or now mostly lost. And once matter itself begins to look this carefully managed, the next step is inevitable. We have to look at places where heat touched entire walls, where stone became glass, where crystal was shaped with a patience that borders on obsession, and where light enters an object as if someone long ago already knew it would. If stone and metal were not enough to trouble the timeline, heat arrives next like a second verdict. Heat changes everything it touches. It reveals what a culture can control and what it cannot. It also leaves signatures that survive long after belief has faded. Recently, researchers fed thermal alteration data, drone scans, mineral transforms, optical surface maps, and excavation records into AI models designed to detect non-random heat patterns in ancient sites and artifacts. What returned was a chain of cases in which fire appears not merely destructive, but organized, directed, and, in some places, far more intense than the old explanations easily allow. The vitrified forts of Scotland are where the air begins to feel stranger. Even the name has a dreamlike severity to it. Vitrified, as if stone itself passed through some brief terrible softness and then stiffened again into witness. These hill fort walls, found across Scotland and in parts of continental Europe, contain stones fused by high heat until they partially glassed together. For years, the standard answer hovered between accident and strategy. Timber-laced walls burned in warfare. Perhaps intentional strengthening by fire. Perhaps catastrophic destruction. Perhaps, and perhaps is honest enough as far as it goes. But honesty deepened when thermal simulation AI began testing these explanations against the actual distribution of vitrification in the walls. The models considered wall thickness, fuel load, airflow, burn duration, stone chemistry, and probable ignition pathways. What they found was not impossible under natural fort fire conditions. Yet in several examples, the heat pattern appeared oddly selective and oddly thorough. Some zones were fused more evenly than uncontrolled collapse would favor. Some sections seemed to receive temperature intensity difficult to sustain with the fuel assumptions normally proposed. That is the part that lingers. Not impossible, just irritatingly exact. Imagine standing beside one of those walls at dusk. Moist air moving over rough grass. Heather dark at the edges. The remains under your hand not soft, not melted in any dramatic cinematic way, but subtly altered. Edges fused. Textures changed. Surfaces whispering that they once knew temperatures no ordinary defensive fire should have lavished upon them. The stone would feel cool now. That almost makes it worse. A cold witness to forgotten heat. Researchers also trained computer vision systems on microscopic surface textures from vitrified material, comparing them with samples produced in laboratory burns, industrial furnace tests, lightning strikes, and naturally occurring thermal alteration. The ancient surfaces did not belong cleanly to any one category. Some resembled prolonged heating rather than brief combustion. Others suggested repeated exposure or complex internal burn behavior. Once again, the result was not a wild, forbidden answer. It was a refusal to settle comfortably. And whenever the data refuses comfort, the room gets quiet. From Scotland, the story bends toward crystal, which is less violent on the surface, but no less disturbing. Crystal has a way of making people careless. They either fall into instant mysticism or instant mockery. Both reactions lose the texture of the object itself. Recently, optical engineers and conservators used AI-assisted surface analysis on crystal artifacts, including several controversial skulls and ritual pieces, asking how their polish, curvature, internal stress behavior, and symmetry compare with both ancient known methods and modern tool signatures. The outcomes varied. Some objects clearly betrayed later intervention. Others remained much harder to dismiss. Take the crystal skull problem carefully. It is a nest of argument, and a fair amount of nonsense has grown around it. Some famous specimens were almost certainly refined with modern tools, or at least heavily reworked. That must be said. Yet when the models isolated certain surface zones and internal optical effects, a smaller and more unsettling question remained. Why do some crystalline pieces exhibit polishing regimes and symmetry transitions that are difficult to map onto straightforward hand abrasion without enormous labor and unusually stable technique? That does not make them alien. It makes them exact. There is a difference between fantasy and exactness, though people confuse them all the time. Exactness is much stranger. Fantasy leaves when the lights come on. Exactness sits there under the lights and asks you to measure again. Imagine a crystal object turning slowly in candlelight, not flashing wildly, just holding light, slowing it, nudging it inward and back. Quartz is stubborn. It resists easy shaping. It fractures according to its own laws, not according to human impatience. To bring it into complex form without destroying clarity requires planning, restraint, and immense time. Optical AI comparisons suggest that certain ancient or supposedly ancient crystal objects were shaped with a disciplined awareness of how light travels through internal planes. In other words, someone was not only carving matter, they were thinking through transparency. The same quiet intelligence appears in ancient lens claims. Rock crystal lenses from the Near East and Mediterranean world have long been treated as curiosities, sometimes useful, sometimes ritual, sometimes dismissed. But machine analysis of curvature, magnification behavior, and polish consistency has reopened the question. A number of ancient lenses perform better than casual description would imply. Some may have served practical visual functions. Others might have concentrated light or been used in inspection work, ritual display, or controlled fire starting. The Nimrud lens is the famous example, though its exact purpose remains debated. Some scholars see ornament, Others see magnification. The AI systems did something beautifully unsentimental with it and related artifacts. They modeled usable focal behavior under plausible ancient handling conditions. The results suggested that at least some of these objects were functionally optical, whether or not that was their only role. Once you allow that, a larger door opens. A culture experimenting seriously with polished crystal and curved transparency is a culture learning how light behaves under human control. Light under control is one of those thresholds. History does not always notice when it crosses it. Then there are the heat-altered stones and ceramics found at a range of ritual and urban sites. In some cases, the issue is kiln sophistication. In others, it is thermal treatment of pigments, glazing, or mineral transformation. AI-based mineral phase reconstruction has recently allowed researchers to estimate temperature regimes from tiny structural changes in archaeological fragments. Certain results point toward firing consistency and heat zoning better than older assumptions permitted. Again, the pattern repeats. Mature behavior appears early, or appears without enough visible apprenticeship stages in the surviving record. I keep returning to that phrase, visible apprenticeship stages, because it sits at the center of so many ancient anomalies. Perhaps the stages existed and simply did not survive. That is possible. It may even be likely in many cases. Yet, when object after object looks like the graduate without enough surviving students before it, suspicion becomes natural. Not theatrical suspicion. Scholarly suspicion. The kind that sits quietly with a cup gone cold and stares at a data set longer than anyone intended. One especially eerie branch of the research touched on fulgurites and vitrified surfaces near ancient sites. Fulgurite, those glassy, tubular traces left when lightning transforms sand or soil, have their own unmistakable morphology. AI systems trained on fulgurites, kilnslag, vitrified masonry, and furnace waste were asked to classify contested samples from site surroundings. Several cases showed mixed signatures, suggesting either unusual environmental histories or human heat events superimposed on already strange geologies. Not clean answers. Just more reasons to stop speaking with such rehearsed certainty. There is a human temptation, when faced with these puzzles, to reach too quickly for one master explanation. Lost energy weapons. Ancient furnaces beyond belief. Forgotten chemical systems. Catastrophic warfare. Secret science. Most of these explanations become silly the moment they are spoken too loudly. But the quieter possibility is harder to shake. Ancient people may have possessed local, guarded, surprisingly sophisticated methods for generating and directing heat at scales we still underestimate. Not magic. Not omnipotence. Just competence stored in traditions that did not survive intact. And competence can disappear with astonishing speed. A workshop burns. A lineage ends. A patronage network collapses. A city is abandoned. Suddenly, what once seemed ordinary within one craft tradition becomes miraculous to a later world that no longer remembers the steps. That may be the truest and saddest explanation for many anomalies. Not impossible civilization. Interrupted civilization. Still, interruption alone does not remove the force of the evidence. If whole techniques vanished, then the timeline remains incomplete all the same. At some sites, even the layout of walls and chambers begins to hint that fire and resonance were considered together. Researchers working across the Mediterranean used AI to cluster architectural spaces by thermal endurance, acoustic response, and likely lighting behavior. Unexpected linkages appeared. Certain ritual rooms that had already raised acoustic questions also proved unusually resilient to controlled burning or heat exposure. That does not prove ceremonial technology in any dramatic modern sense, but it does suggest integrated environmental thinking. Space, sound, heat, and light considered as one field rather than separate problems. I think that is what most disturbs the modern eye when it looks closely enough. The ancients were not always compartmentalized the way we are. A chamber could be a sacred room, an acoustic body, a thermal envelope, and an astronomical marker all at once. A crystal could be ornament, optical aid, and ritual focus in the same object. A wall could defend, resonate, and endure heat in ways its builders understood without writing us a manual. By now, the room in which we are sitting feels almost like a little laboratory of its own. Fire in one corner, shadows on the walls, glass somewhere holding light differently from wood or cloth. The body noticing temperature before thought catches up. That is as it should be. These old mysteries are easier to understand through sensation than through argument alone. Picture again one vitrified wall in the Scottish dim, one crystal artifact turning slowly under a lamp, one ancient lens catching a line of flame and narrowing it into brightness. None of these scenes needs melodrama. Their strangeness is already sufficient. The AI did not discover fantasy hidden in the past. It discovered patterns of control, patterns of finish, patterns of heat and light that imply more intention, more sophistication, and more vanished knowledge than the smoother version of history likes to allow. And once light itself begins to look curated, once heat begins to look directed, the path naturally leads away from matter and into memory, into maps, into parchment, into coastlines that should not be there yet. Because after stone, metal, fire, and crystal have all become uneasy. Even geography starts to look as if it may have been remembered by someone earlier than we were told. The next layer of the mystery does not sit in stone or metal at all. It waits on paper, in ink, in coastlines drawn by hands that should not have known what they were drawing. Recently, historians, geographers, image analysts, and AI researchers fed early maps into neural systems trained to compare coastlines, projection habits, copying errors, latitude drift, and known historical source chains. The purpose was simple: not to prove a legend, but to test whether certain old maps preserve information that exceeds what their makers are supposed to have known. The result was deeply uncomfortable. Some anomalies vanished under scrutiny, which is only fair. Others did not vanish at all. They sharpened. Imagine an old map unrolled across a wooden table in a room lit by one hard yellow flame. The parchment is dry at the edges and soft in the middle from handling. Salt may have touched it once. so may breath from a navigator leaning close enough to smell the ink. A line bends south. Another curves into water. A note is written in a margin by someone long gone, someone whose hand shook just slightly at the end of a word. These things do not look dangerous at first. Maps rarely do. They look patient. But patience can be its own kind of threat. The most famous case is the Piri Reis map. It has become so overused in grand speculation that many careful people would rather not touch it at all, which is a pity, because even stripped of its wilder claims, it remains eerie. The surviving fragment, drawn in the early 16th century by the Ottoman admiral Piri Reis, shows parts of Europe, Africa, and South America. He tells us directly that he compiled older source maps, including some associated with Columbus. That matters more than the sensational retellings usually admit. The map presents itself not as pure invention, but as compilation, a vessel carrying older memory. Researchers recently used AI-based coastline comparison to test the southern land shapes against known distortions from medieval portolan practices, Ottoman copying habits, and projection drift. Many supposed miracles weakened under this kind of pressure, which again is healthy. But the unsettling part remained the same. The southern contours do not sit cleanly inside any single expected model. Some portions resemble South American extension, distorted by copying. Other portions encourage comparison with ice-free Antarctic arguments, especially in older speculative literature. Mainstream historians reject those claims, and there are strong reasons to reject them. Still, the models found the shape unusually stubborn. It refuses to settle down politely. That refusal matters because it repeats elsewhere. Archaeologists and historians also brought in the Oronce Fine map, the early 16th century world map that has likewise been accused of showing Antarctica before discovery. AI systems were asked to compare the landforms not only against Antarctica, but against the full range of early modern southern continent conventions, decorative symmetry habits, and inherited classical geography. Once again, some apparent precision dissolved into style, yet some of the broad structural correspondences remained annoying enough that the system kept flagging them for closer review. Not proof, just persistence. I think persistence is one of the quiet themes of this entire story. A single anomaly may be an accident. A repeated anomaly becomes atmosphere. Enough atmosphere, and the accepted room begins to feel short of air. The researchers then widened the net. They included medieval Arctic maps, Renaissance polar diagrams, and obscure geographical works that tried to turn rumor into measurement. That is where the northern story grew stranger. Some old maps depict circular islands, divided polar regions, central mountains, converging waters, or coastlines that look suspiciously structured for worlds no explorer had properly reached. Historians usually explain this as inheritance from classical myth, copied error, theological symmetry, or cosmological design. Those explanations are often sound. Yet, when AI tools compared these shapes across map traditions, a second possibility surfaced. Some patterns may preserve layered memory, ancient rumor refined by repeated copying, partial observation wrapped in symbolic geometry, and old source material no longer extant. That possibility is not romantic in the cheap sense. It is bureaucratic. Someone copied something because it seemed worth preserving. Then someone else copied the copy. Then another pair of hands straightened one coast, bent another, added a legend, removed a bay, shifted a title, yet kept the same broad structure. Across centuries, the original reason may vanish, while the form survives. Maps are very good at doing that. They preserve a skeleton after the voice has gone. One team used AI to model copying descent, the way manuscript scholars model families of texts. They treated maps like documents with inherited errors, asking which features behave like direct observation and which behave like copied memory. Some coastlines acted like observations. Others acted like stubborn inheritance. That is an extraordinary phrase. Stubborn inheritance. It means a feature remains because too many later hands felt compelled to keep it, even when it no longer matched confident knowledge. If you have ever stared at an old chart in a quiet archive, you know the feeling. The map seems to be speaking in two languages at once. One is practical. Sandbank here. Harbor there. Current. Cape. River mouth. The other is older and more nervous. A coastline too smooth. An island too regular. A place name carried forward after the place itself has become doubtful. History on one side, memory on the other. That is where the AI work became most interesting. Researchers overlaid some of the stranger northern and southern charts against modern submerged shelf maps, paleo coastline reconstructions, and glacial maximum sea level models. They were careful not to overstate the correspondences. Most of them are partial, speculative, or highly sensitive to projection choice. Yet, a few alignments proved uncomfortable enough to keep the room awake. Certain shallow continental shelves and drowned coastlines seemed to shadow forms preserved in older mapping traditions, better than chance alone would make comfortable. Doggerland in the North Sea has already taught us that lost landscapes can survive in folklore and fragmentary geographical memory long after they drown. The shelves of the Arctic, the submerged plains around once exposed corridors, and the possibility of ancient coasts now hidden beneath water all return to the same question. How much can a map remember when the land itself has gone away? The answer may be more than we like. I have always found maps more haunting than monuments for exactly that reason. A monument tells you that someone was here. A map tells you that someone looked, measured, compared, and expected another human mind to understand later. It is a direct act of trust across time. That trust becomes eerie when the later mind cannot explain how the earlier one knew enough. The Piri Reis problem, then, is not only about Antarctica, and it is certainly not only about one admiral. It is about source chains, about lost archives, about coastal memory moving farther than ships, about whether geographical knowledge sometimes survives through damaged transmission rather than continuous, open discovery. The same may be true of medieval polar lore, of classical northern descriptions, of Arab geographies, and of old Chinese records that describe lands of strange light and unusual orientation. Not all of them are factual in a hard sense. But not all of them feel comfortably invented either. As the AI clusters these maps and associated texts, one pattern appears again and again. The edge of the world is rarely empty in human memory. Even when blank on paper, it fills with structured possibility. Islands, continents, openings, circles, currents, lands of long daylight, lands of preserved order, lands that seem at once remote and remembered. That repetition does not prove one hidden civilization. It does something quieter. It suggests that forgotten geography may survive in forms that later ages cannot fully decode. There is also the older Babylonian world map problem, less theatrical than the Renaissance charts, but in some ways more intimate. A small clay tablet can carry a cosmology so compactly that later readers mistake it for fantasy alone. Yet whenever systems compared its river logic, peripheral regions, and directional framing with other early geographical texts, they found something worth pausing over. Even symbolic maps often preserve practical orientation habits. The sacred and the navigational live side by side. Once that became clear, researchers began looking for hidden continuity between symbolic world diagrams and later exploratory charts. Not direct descent in a simple family tree, but recurring habits of spatial memory. Center, river, margin, distance on, island, beyond. That beyond keeps returning. Arab geographers offer another soft disturbance. Their texts often combine measured travel knowledge with inherited reports of strange northern or southern conditions. Long daylight, frozen seas, altered magnetism, and difficult horizon. AI term matching across Arabic, Greek, Latin, and later vernacular sources showed that some supposedly fanciful descriptions cluster around real environmental phenomena. Midnight sun, magnetic drift, ice edge behavior, false islands created by fog and light. Once you admit that ancient and medieval reports can braid fact and myth without warning, the maps start to look less dishonest and more layered. Layered is the right word. A coastline observed in one age may be corrected in another, then decorated in a third, then copied piously in a fourth by someone who trusts the tradition more than the sea. That is how knowledge survives damage. Not cleanly, not scientifically in the modern sense, but stubbornly enough to remain visible when AI tools flatten the noise and search for repeating form. Perhaps that is why the old cartographers feel so human to me. They could not bear a blank edge. Blankness felt false. Some part of them sensed that the world extended beyond official sight, and that older memory still clung to the margins. So they drew. They drew rivers flowing toward invisible centers, islands too neat to be accidental, coasts that half remembered drowned land, and regions where light itself behaved strangely. They drew as if inherited rumor deserved measurement, and that instinct, however flawed, may have preserved more than any one of them understood. And if that is true for maps, then it may also be true for words. Because the next archive is stranger still. Once researchers turned the same AI methods toward ancient texts and images, the anomalies shifted from coastlines into language itself. Technical phrases, repeated object descriptions, ritual images that behave less like myth once they are compared across cultures and translation layers. The old question returns in a new form. What if some texts are not only telling stories? What if they are trying, in damaged human language, to preserve procedures, devices, and ideas whose original context was lost? That possibility drew together philologists, engineers, Sanskrit scholars, Assyriologists, historians of science, and computer vision teams. Their work began with a modest premise. Compare not what modern people want ancient texts to mean, but what the texts repeatedly do say when translation bias is reduced. Cross-reference the terms. Track the verbs. Follow the technical nouns. Model the images by geometry, not by romance. When they did, the old world began to sound less dreamy and more operational. Which is where we go next. Away from coastlines in ink and toward jars, reliefs, diagrams, and words that may remember machines long after the machines themselves were gone. If maps preserve memory in line and coastline, texts preserve it in stranger ways. They preserve it in repeated terms, in descriptions that sound ceremonial until you compare them with technical language, in images dismissed as symbolic until geometry begins to make them difficult again. Recently, researchers used large language models, image recognition systems, and cross-cultural term matching tools to compare ancient descriptions of vessels, power, flight, light, and mechanism across Sumerian, Akkadian, Sanskrit, Egyptian, Greek, and Chinese sources. The work did not prove that the ancients had every modern machine people have ever projected onto them. Much of that noise still deserves to be left in the noise. But several clusters of description became harder to laugh away once the systems stripped out translation habit and looked only for repeated structure. Let us begin with the Baghdad Battery, because few objects sit so stubbornly between ridicule and unease. A clay jar, a copper cylinder, an iron rod, residues inside, simple enough to sound almost disappointing. And yet when reconstructed with acidic electrolytes, similar arrangements can produce small electrical potential. That fact alone does not prove an ancient battery network or a forgotten electrical civilization. It proves possibility. The more interesting question is whether the jar and related finds make better sense as storage, ritual, or electrochemical device. Researchers trained AI systems on object typology, corrosion signature, known container classes, and experimental reconstructions. The systems compared the jar to ordinary storage vessels, ritual capsules, scroll containers, and electrochemical assemblies. The result was not decisive. It rarely is in the ancient world. But the electrochemical interpretation remained more structurally viable than many scholars had preferred to admit. When residue analyses and plating experiments were added to the dataset, the room grew quieter. Some ancient gilded surfaces, especially on small objects, are at least compatible with low-voltage electrodeposition methods or chemically assisted processes more sophisticated than casual historical summaries suggest. The point is not that ancient Mesopotamians were charging lanterns under temple roofs. The point is subtler. They may have discovered localized electrical or electrochemical behaviors and used them pragmatically without ever developing the theoretical language modern science later built around those effects. That is how many technologies begin. Not as universal systems, but as pockets of controlled surprise. Imagine a workshop room with clay jars lined along a wall, copper catching firelight, sour smell in the air from fermented liquid or acid, hands stained from metalwork. A craftsperson noticing that one arrangement does something another does not. A faint transfer, a brightening of surface, a shock perhaps, small but memorable. Knowledge like that can survive without theory if it remains useful enough to repeat. From Mesopotamia, the inquiry moved eastward into Sanskrit literature, and here the atmosphere changes completely. The problem with ancient Indian technical descriptions is not lack of material. It is overabundance, layered redaction, and centuries of interpretation burden. Some texts that later writers celebrate as manuals of aerial craft are almost certainly late, composite, or highly symbolic. That has to be said with full clarity. Yet the newer AI translation work did something valuable. It separated style from function as much as possible. It tracked nouns associated with structured movement, enclosure, propulsion, heat, and metal. It mapped which phrases cluster in poetic language and which cluster in procedural language. That distinction matters more than people think. A poet can say that a god flies in a radiant chariot. A technical writer tends to repeat material constraints, dimensions, maintenance language, and operational verbs. The models found that certain passages long dismissed as mystical showed surprisingly dense clusters of procedural vocabulary, though often buried inside later religious framing. Not enough to claim aircraft in a modern sense. Enough to suggest that some traditions preserved damaged memories of engineered conveyance, controlled heat, or enclosed motion. When you read such passages slowly, without demanding too much from them, they begin to feel less like science fiction and more like fossil vocabulary. Words surviving after the original apparatus has vanished. Terms for chamber, frame, bending, heated material, directional motion, and observational use. AI cross-comparison with known craft texts, from chariot making to temple construction, found overlaps that kept the possibility open. Not certainty. Operational residue. Operational residue is exactly the kind of thing civilization forgets while still repeating. The same pattern appears in Chinese accounts of automata. Ancient Chinese texts preserve stories of mechanical birds, artificial musicians, moving figures, and highly skilled artisans whose constructions behaved with unnerving, lifelike precision. Many readers turn away at once, assuming fantasy. Yet historians of technology have long known that early Chinese engineering was deeply inventive, especially in mechanisms, water-driven systems, clockwork precursors, and automaton design. The AI studies made the old accounts more interesting by clustering mechanical descriptions according to plausibility. Decorative impossibilities fell away. A smaller set of narratives remained closely aligned with known engineering principles, including articulated movement, concealed drives, airflow effects, and hydraulic timing. What surprised the researchers was not that ancient Chinese texts include mechanical wonders. We already knew that. It was the degree to which some descriptions behave like compressed technical memory rather than pure legend. Once again, we are not dealing with one giant forbidden answer. We are dealing with a civilization that may have preserved fragments of practical engineering in stories later readers misunderstood as marvels detached from method. Then comes Egypt, where the argument grows more dangerous because modern projection has already done so much damage. The Dendera reliefs are the obvious example. Some people see electrical lamps immediately and then stop thinking, which is a pity. Others refuse even to look because the association has become embarrassing. Recently, researchers used image segmentation AI to strip the reliefs into component forms, then compared those forms with Egyptian symbolic vocabularies, ritual iconography, and modern projected analogies. The result was refreshingly strict. No, the reliefs do not straightforwardly depict modern light bulbs. But the analysis also showed that some structural relationships in the scene, enclosure, support, linear extension, neste foam, and operator position, are why modern viewers keep experiencing technological recognition. The resemblance is not arbitrary. It emerges from geometry. That does not make the relief a schematic of electrical equipment. It does make it more interesting than either side usually admits. There is a difference between saying something is modern technology and saying it encodes a visual grammar of contained radiance, structured energy, or process symbolism so precise that it repeatedly triggers technical comparison. The AI could not resolve the debate. It clarified why the debate refuses to die. The same refusal appears in Sumerian descriptions of the me, usually translated as divine powers or decrees. The term sits halfway between theology and administration. But language models trained on broad corpora found that in context, the me often behaves less like abstract spirituality and more like transferable packets of authority, shil, or functional capacity. When Anki gives or loses the me, the narrative can sound uncannily like controlled distribution of specialized knowledge sets, not microchips hidden in myth. No, something more human and more haunting. The memory that civilization itself can be handed down in modules. That interpretation matters when placed beside the Apkallu traditions, the sages who bring knowledge from before or from beyond the ordinary human sphere. AI-based text analysis of these figures across Sumerian, Akkadian, and later retellings showed stable associations with architecture, writing, ritual order, measurement, and controlled transmission. That is a striking profile. These are not just holy men. They are culture engineers in narrative form. I have always found that phrase, culture engineers, oddly moving. It suggests that ancient people understood civilization not as spontaneous bloom, but as delivered method. Greek material offers its own unsettling case in the Antikythera mechanism, though it belongs partly to a later world. Epheso. It deserves a place here because it behaves like the visible, surviving tip of a larger, lost tradition. Gear trains, astronomical cycles, predictive capacity, compact mechanical intelligence. Researchers used AI to reconstruct missing tooth counts, dial relationships, and user sequence logic. The machine emerged not as a miracle born alone, but as the product of an already mature engineering culture. That implication may be the most chilling thing about it. The device is astonishing, yes. More astonishing still is the likelihood that it once had cousins. And if one cousin survived by shipwreck, what else failed to survive by accident? That question pushed the research teams back toward archives, toward scattered mentions of self-moving statues, temple doors that opened by hidden force, mirrors that concentrated heat, speaking tubes, signal fears, coded drums, and optical aids. Most of these remain individually explainable. That is not the issue. The issue is density. Once AI systems clustered them across cultures, a persistent image formed. Ancient civilizations repeatedly describe controlled phenomena involving light, motion, force, resonance, and signal transfer in ways too structured to reduce entirely to poetic excess. Some of this may be convergent imagination. Some may be ritual metaphor. Some may be direct technical memory. The honest conclusion is mixed. But the mixed conclusion is powerful enough. It means the archive cannot be safely treated as either literal machine manual or decorative fantasy. It is a damaged middle category. And damaged middle categories are where the most enduring mysteries often live. The room grows quieter at this point in the journey because the implications are more intimate. A strange map can still be kept at a distance. A text is harder. Text gets into the mouth, into memory, into prayer, law, ritual, teaching. If ancient language carries technical residue, then later civilizations may have been living among broken instructions without realizing it, repeating old words whose original use had gone dark. That thought changes the feeling of the archive entirely. The library is no longer just a place of story. It becomes a graveyard of procedures, shelves of compressed memory, clay and papyrus and parchment holding fragments of operating language after the machines, methods, or institutions that once gave them clear meaning had vanished. If you were standing in such an archive after everyone else had gone home, with only one lamp still awake and dust hanging where the light finds it, I think you would feel exactly what I feel now. Not certainty, something more delicate. The sense that civilization may forget by translation, that we do not always lose knowledge by fire or flood. Sometimes we lose it by continuing to copy the words after we have lost the world that made the words obvious. That is why this part of the story does not end in a grand revelation. It ends in a thickening unease, jars that may have known current, reliefs that trigger technical recognition for structural reasons, Sanskrit passages that preserve procedural density inside mythic language, Chinese stories that compress engineering into marvel, Mesopotamian terms that behave like transferable knowledge systems, a Greek mechanism too advanced to be comfortably alone. All of it adds weight to the same old suspicion. The ancient world may have known more, and worse. It may have known it in ways later. Ages could only half remember, which is where the next layer takes us. Away from device and diagram, and toward the body itself, toward skulls, bones, lineages, and mechanisms hidden in flesh and bronze that make the timeline shiver in a different register entirely. By the time the story reaches bone, the room changes again. Stone can disturb you. Metal can trouble you. Old maps can make the horizon feel unreliable. But bone is intimate. Bone is what remains when every tool has fallen quiet. Recently, researchers used AI models to compare cranial measurements, burial reports, skeletal anomalies, old newspaper archives, museum catalogs, genetic studies, and disputed excavation notes from several continents. The goal was not to prove one sensational theory. It was to see whether the same outlier patterns kept returning after exaggeration, fraud, and repetition were filtered away. What emerged was not a clean revelation. It was a colder thing, a statistical residue of bodies and mechanisms that do not always sit where the official timeline wants them to sit. The first unease comes from elongated skulls, especially those from Paracas in Peru, though they are not the only examples. At a distance, they can be explained away easily enough. Cranial binding, people say, and often they are right. Human cultures have long shaped the skull in infancy through pressure and wrapping. That is real. That is documented. Yet the newer AI work did something more careful than the old arguments. It separated shape classes. It compared known intentional deformation patterns from many cultures with three-dimensional scans of skulls that have remained controversial for decades. Some of the Paracas examples clustered where expected. Others did not. The difference was not theatrical. It was subtle. Cranial volume distribution, suture pattern behavior, base structure, and posterior extension created a small but persistent group of specimens that fit poorly within standard deformation models. That does not mean non-human. It does not mean hidden species. It means the group deserves more careful attention than dismissal usually grants it. The AI teams cross-referenced the skull data with soft tissue assumptions, infant pressure models, and known anatomical change under binding. In several cases, the output suggested that deformation alone may not fully account for the final shape. I think what disturbs me most here is not the claim itself, but the quietness of the objects. A skull in a museum case does not shout for interpretation. It lies there under soft light, empty and patient, while generations of visitors pass it by with only a quick look. Yet once you imagine the measurements running behind the glass, once you imagine a model comparing curvature and internal volume against thousands of known cases, the stillness becomes heavier. The object begins to feel like an unanswered sentence. Similar unease appears in older reports of giant skeletons. This territory is crowded with nonsense, hoaxes, exaggerated journalism, and recycled folklore. So caution is not optional. Researchers knew that. They fed large corpora of 19th and early 20th century newspapers into language models trained to identify repeated reporting chains, copied phrasing, fraud signatures, and provenance weaknesses. A huge amount of noise collapsed immediately. Many stories traced back to the same small set of sensational articles. Others showed obvious signs of fabrication. But again, not everything vanished. A smaller archive remained. Scattered local reports, museum references, excavation summaries, and correspondence describing unusually tall skeletons that had once been catalogued, displayed, or shipped, then later disappeared into institutional silence. The AI could not confirm that all of these represented true giants in the legendary sense. What it could show was that the pattern of disappearance itself was real enough to merit discomfort. Objects reported, measured, sometimes photographed, then lost, reclassified, or folded into vague storage language. That pattern matters because it keeps returning whenever the archaeological record becomes inconvenient. Not always a conspiracy, perhaps. Sometimes simple neglect. Sometimes bad storage. Sometimes the ordinary erosion of archives. But when extraordinary human remains repeatedly slip from public visibility, suspicion becomes less childish than people pretend. The so-called star child skull belongs to a different branch of the same unease. Found in Mexico and subjected to years of conflicting analysis, it has attracted both serious curiosity and more nonsense than it deserved. The newer AI-based morphological comparison work did not validate its most extravagant claims. It did something more disciplined. It demonstrated that the skull combines several features that are rare in combination, including unusual cranial shape, orbital proportion, and certain structural irregularities that do not align cleanly with one standard pathology. That still leaves many natural explanations. Deformity, disease, developmental anomaly. Those remain plausible. Yet the case stays open because the object does not submit gracefully to easy closure. And then there is DNA, which always sounds like the modern final word until it turns out to be another room with more doors than walls. Ancient DNA has transformed the study of human movement, ancestry, and adaptation, but it has also made the story of our species much less tidy. Recently, AI systems were used to compare ancient genomes, migration corridors, burial contexts, and physical morphology in ways older human analysis would have struggled to handle at scale. The result was a denser picture of human variety than the old linear story liked to admit. Populations mixing, separating, returning, adapting, disappearing. Lineages once thought isolated, proving linked. Traits once thought local, proving unexpectedly mobile. None of this proves a lost race in the fantasy sense, but it does reinforce a darker and more interesting truth. Human history is full of branches, pockets, outliers, and vanished forms. We have been simpler in the textbook than we ever were in the ground. That matters because once a culture is already willing to smooth over biological complexity, it becomes easier to smooth over technological complexity too. The timeline does not merely organize the past. It edits it. The edit becomes almost impossible to ignore when the body gives way to mechanism again. This time, underwater, inside corrosion, inside one of the most unsettling objects ever pulled from an ancient wreck. The Antikythera mechanism still has the power to silence anyone who looks at it long enough. Bronze fragments at first, greened by sea and time, broken into a puzzle that should not exist in its century with such confidence. Yet it does exist, and every modern examination makes it more rather than less astonishing. Researchers have now used AI reconstruction models on the surviving fragments. Gear teeth, unscription trace, and possible missing components. The system was trained not just on known ancient gearwork, but on mechanical logic, astronomical cycles, and design efficiency under bronze constraints. What emerged was not merely a calendar. It was a compact, predictive machine of enormous elegance, capable of modeling celestial cycles with a precision and conceptual sophistication that feels almost misplaced in its accepted context. The most disturbing thing about the mechanism is not that it is advanced. It is that it is too mature. You know that feeling when you find one object that implies a whole missing world behind it. This is that feeling in bronze. The gears do not look like an experimental first attempt. They look like the surviving representative of an existing tradition, a craft lineage, a design culture, teachers, workshops, failures, refinement, predecessors. The AI reconstruction teams kept returning to the same conclusion. This device is unlikely to have been alone. If it had brothers, where are they? Lost to melting, shipwreck, plunder, neglect, or corrosion perhaps. History is excellent at destroying precision. A mechanism can vanish much faster than a myth. Bronze is reusable. Gears are not sacred once their meaning is forgotten. A city burns. A temple falls. A ship sinks. And the machine world of antiquity narrows into a few green fragments in salt water. That image stays with me. Bronze teeth sleeping for centuries below black waves, then rising again into light only to embarrass the chronology of invention. We are told to think of computation, prediction, and fine gearing as fruits of much later development. Yet here is the device, quiet and undeniable, telling us that someone in the ancient Mediterranean could imagine the heavens as a mesh of interacting cycles and then embody that imagination in metal. The AI work also compared the mechanism with later Islamic and medieval geared instruments, not to erase the later achievements, but to test conceptual continuity. Certain design principles reappear, though not always directly. What matters is the possibility of interrupted inheritance. Knowledge may not move in a clean line. It may flash, vanish, and return in altered form, like light seen across water between waves. That possibility draws bone and bronze together in a way I did not expect when I first entered this material. On one side, bodies whose forms challenge the simplified picture of human sameness. On the other, a machine that challenges the simplified picture of human technical development. The official story likes gradualness because gradualness is comforting. It means nothing truly strange ever happened. It means no entire world of skill has gone missing. It means every advance has an obvious staircase behind it. But the ground, and the sea, and the old reports, and now the AI models keep hinting otherwise. Not always, not everywhere, but enough. As the fire lowers, I find myself thinking less about proof and more about humility. Ancient people may have been more various than we allow, more adaptive, more inventive, more difficult to categorize. Some skulls may be nothing more than unusual bodies or difficult cases of deformation. Some giant reports may never rise above rumor. Some mechanisms may be rare marvels rather than signs of a widespread lost science. All of that remains possible. But the pattern persists. The archive of exception is too dense to dismiss with one tired gesture. And when exception becomes dense enough, it starts to look like policy that history forgot to admit. That is where the last part of this journey waits, not in one more object, but in the atmosphere around all the objects, in energy anomalies, in sealed storage, in awkward museum language, in the strange social instinct to hide, mock, or soften whatever threatens the smoother story of progress. The final question is not only what ancient people knew, it is why the modern world so often behaves as though it would prefer not to know. By the time we reach the final chamber of this story, the mystery has changed shape. It is no longer only about one wall, one blade, one map, one skull, or one machine. It is about the pressure that gathers when too many anomalies lean in the same direction. Recently, researchers used AI to combine excavation records, geophysical surveys, material analyses, institutional publication histories, storage catalog, and public-facing museum descriptions, asking a question that sounds almost impolite. Where does evidence become socially inconvenient? The answer was not a dramatic secret file stamped in red. It was a pattern of avoidance, minimization, delayed release, vague language, selective emphasis, and sudden loss of confidence whenever ancient material begins to hint at knowledge systems more advanced, more integrated, or more cyclical than the accepted timeline prefers. One branch of that discomfort lives in energy anomalies at ancient sites. This is dangerous territory because exaggeration breeds fast there, and the modern imagination is always eager to turn every sacred hill into a power plant. Still, the data has its own gravity. Researchers have measured unusual electromagnetic fluctuations, conductivity patterns, resonance effects, mineral alignments, and thermal irregularities at certain major ancient monuments. Not all of these are mysterious. Geology explains a great deal, and should explain a great deal. But once AI systems began clustering the readings across multiple sites, an awkward feature appeared. Some monuments seem to have been placed, oriented, or engineered in ways that repeatedly coincide with zones of environmental peculiarity. At Giza, for example, electrical engineers and geophysicists have long argued over internal conductivity behavior, piezoelectric potential in granite-containing quartz, and the unusual acoustic character of certain chambers. The newer AI analysis did not conclude that the pyramids were machines in any crude modern sense. It did show that their material combinations, void structures, and chamber placements create a physical environment far more dynamically interactive than a simple tomb model would lead one to expect. Sound behaves strongly there. Static effects appear under some conditions. Thermal and moisture behavior differ from surrounding structures in patterned ways. None of that proves lost power generation. It does suggest that the builders may have cared about the physical behavior of enclosed space more than funerary explanations alone comfortably cover. Similar unease attends sites like Stonehenge and Karnak, where lithic alignments, subsurface water, magnetic variation, and acoustic response sometimes overlap. Again, geology matters. Water tables matter. Mineral content matters. Yet the question refuses to leave. Why do some of the most symbolically charged sites also behave like environmental amplifiers? Why do so many sacred places sit where resonance, conductivity, sightline, and seasonal light all seem to gather in the same breath? Perhaps because ancient builders understood such gathering better than we do. Or perhaps because they felt it bodily and built where the world already seemed more awake. That phrase may sound soft, but soft phrases are sometimes the most honest when the hard ones overpromise. The AI teams also studied publication behavior. This was one of the strangest parts of the whole project. Instead of looking only at artifacts, they looked at the language institutions use when describing artifacts. Museum labels, catalog entries, journal abstracts, storage notations, grant summaries. They compared how ordinary finds are discussed versus how anomalous finds are discussed. The differences were subtle, but once seen they were difficult to ignore. Unusual objects attract words like probable, possible, ceremonial, symbolic, unclear, intrusive, contaminated, or disputed at sharply elevated rates, even when the supporting data is no weaker than for many accepted interpretations. Some of that caution is responsible scholarship. We should want caution, but the models suggested something else as well. A reflex of containment, an institutional instinct to prevent local anomaly from growing into timeline challenge. In other words, the more an object threatens the story of gradual progress, the more aggressively the language around it becomes soft, postponing, or marginal. That is not necessarily deception. It may simply be professional survival. Whole careers, departments, textbooks, exhibitions, and public narratives depend on continuity. Once continuity is seriously threatened, the burden of proof becomes almost inhumanly high. An ordinary claim may pass with moderate support. A disruptive claim is asked to survive artillery. I understand that impulse, perhaps more than I would like to admit. Human beings crave a past that behaves. Museums crave displays that cohere. Universities crave models that can still be taught without every lecture collapsing into caveat. There is comfort in the long staircase. First this, then that, then the next. Stone to copper, copper to bronze, bronze to iron, village to city, chant to writing, myth to astronomy, craft to engineering. But the staircase may be partly an illusion, or at least incomplete. The AI work did not destroy the staircase. It revealed landings where doors seemed to have been bricked over. That is where the final and darkest idea enters. Cyclical history. Across many of the source materials, the same quiet possibility keeps returning. Human civilization may not advance in one clean upward line. It may rise in local brilliance, fracture, lose techniques, preserve fragments as religion or legend, then rediscover what it no longer remembers having once known. This model feels strange only because modernity trained itself to worship accumulation. Yet archaeology itself often tells a harsher story. Collapse is normal. Archives burn. Trade routes die. Specialist knowledge evaporates in 2 generations if institutions fail. A society can forget how to do extraordinary things much faster than it learned them. If that is true, then ancient anomalies stop looking like isolated embarrassments and start looking like surviving pieces of interrupted worlds. A precision stone culture collapses, and later, people inherit the walls, but not the full method. A metallurgical tradition narrows into ritual craft and then disappears. Astronomical knowledge survives in calendars after the instruments are gone. Cartographic memory persists in copied forms after the original coasts drown. Technical language becomes myth because the devices it named no longer exist. Human biological variety is simplified by later categories. Mechanisms sink. Workshops burn. Temples are stripped for brick. The timeline smooths itself because smoothing is what surviving civilizations do when faced with ruins they can use but not fully explain. I think that is why the phrase lost civilization so often goes wrong. It encourages people to imagine one grand vanished empire, shining and singular, when the evidence may point to something more unsettling and more human. Not one lost civilization, but repeated loss. Repeated local peaks of skill, order, and synthesis, followed by reduction. A world in which forgetting is built into the structure of history as deeply as invention is. The fire is very low now. The room around us has grown softer. This is the right moment to say plainly that the AI did not uncover one perfect hidden answer. It did not prove Atlantis. It did not prove one master race of builders. It did not prove that every ancient symbol is a disguised machine. What it did uncover was a landscape of pressure points, places where the official account strains, places where matter, text, geometry, biology, and institutional behavior stop agreeing as neatly as they should, places where the old confidence sounds a little rehearsed. And perhaps that is enough. Enough to make us gentler with the past. Enough to make us less arrogant about our present. Enough to understand that ancient people may have known forms of integration we have mistaken for primitiveness simply because their knowledge was not arranged like ours. Enough to suspect that civilization is not a single rising light, but a field of lamps, some lit, some shattered, some buried, some found again under dust. The phrase, rewrite human history, is used too cheaply these days. Still, I can think of no calmer way to say it. If even a fraction of these anomalies endure serious scrutiny, then the story of humanity is older in its complexity, less linear in its growth, and more tragic in its forgetfulness than most of us were taught. That is not bad news. Exactly. There is grief in it. Yes. But there is also dignity. It means our ancestors were not waiting in dimness for modernity to arrive and grant them intelligence. They were already thinking, measuring, listening, alloying, aligning, navigating, carving, observing, and perhaps losing and recovering knowledge in cycles we still barely understand. The last image I want to leave with you is a simple one. A museum basement, quiet after closing. Shelves of crates. Dust sitting on labels. A drawer opened under low light. Inside, an object wrapped in old paper. A fragment of bronze gear. A polished lens. A skull with a shape that does not quite belong. A map with a coastline no one can comfortably explain. None of these objects is a complete story. But together they make a pressure, and pressure is often where truth begins. So let the pressure remain. Do not force it into certainty. Just allow it to rest in the room with you. The possibility that our past is deeper than our categories. The possibility that the earth has watched civilizations rise and narrow before. The possibility that forgotten knowledge survives not only in ruins, but in ridicule, in hesitation, in the careful way labels are written when an object will not behave. The possibility that history is not hiding from us exactly, but waiting for us to become less certain before it will speak plainly. The old stones are still where they were. The corroded bronze is still patient. The maps still hold their breath. The skulls still lie under glass. And the models, for all their modern brilliance, have really done something very ancient beat. They have compared patterns in the dark and listened for what repeats. What repeats is not one answer. What repeats is the same soft warning. The timeline may be too simple. The past may have been stranger, more skillful, and more cyclical than we were told. And somewhere under the official staircase, there may still be older rooms. If you carry anything from this long descent, let it be that. A little more humility before the dead. A little more patience with anomaly. A little more willingness to admit that history, like the earth beneath ice or sand, keeps more than one layer at a time. The fire is almost gone now. Let the room dim. Let the old questions remain where they belong, close, unresolved, and strangely peaceful. The past does not have to be solved tonight. It only has to be heard. Good night.